Okay, consider the functions f of x and g of x. What are their domains? Well, both of these are polynomial functions, so their domains are both XER. Nothing to it. They aren't rational, they aren't radical, so there's really nothing that can go wrong with those calculations. Express f over g, it's 2x squared minus 13x minus 7 over 2x plus 1. Now, for the domain, as usual, our attention turns completely to the denominator. This must never be 0. So, to get restrictions on the domain, we say 2x plus 1 must never equal 0. And then we solve that. That means 2x must never be negative 1, which means x must never be minus 1/2. So our domain would be x can be any real number except x must not be minus 1/2. As mentioned before, you can factor this numerator and you might even find a 2x plus 1 in it, but it doesn't matter. Even if there is something in the numerator that's identical to 2x plus 1, that doesn't mean you can scratch them out. It means those numbers cancel out for every value except 0, meaning the one in the numerator wouldn't help. The problem would still be there because division by 0 could still occur. And explain two different ways to evaluate f over g of 3. The first way is to take this combined function and plug 3 into it. So 2 times 3 squared minus 13 times 3 minus 7 over 2 times 3 plus 1. You can evaluate that and it'll give you a number. The other way is you could find f of 3, plug 3 just into the numerator, which gives you 18 minus 21. I think it's minus 28. And then calculate g of 3, which is 7. And when you divide those, you get f over g equals negative 4. In other words, f over g of 3 is identical to just plug 3 into the top part and then divide 3 into the bottom part and divide them later. It isn't necessary to do it all in one big lump like this, although you certainly can.